When I do dishes by hand, the ceramic stuff dries really fast, but the stuff made out of plastic, there's always drips stuck onto it for quite a while afterwards. And the consensus is that the greater heat retention of the ceramic allows it to dry faster, but when I hand wash, I don't hand wash all that hot, so let's do some experiments. So I got a Raspberry Pi with a camera module to take a time lapse of a regular dish and a plastic dish to see how fast it dries. And I'm going to put some drops of water on each one of those. First a single drop on each and then a double drop. So here's my time lapse with the plastic dish and the ceramic one. Scrubbing through it by 1 hour and 31 minutes. These drops are gone. And then we have to scrub a lot further to here. 3 hours and 10 minutes, so twice as long for these drops to disappear. So why did the plastic dish take that much longer to dry? So I just put some more drops on here on the ceramic and very close by on a piece of plastic plate. And now I can look at those with my Topdon TC004 infrared camera. And the TC4 Mini is a cost-reduced version of the TC4. More on that later because they're sponsoring this video. And with the plastic on the left, we can see those drops are way cooler than the drops on the right, which are on the ceramic. And looking at that more closely, at the center I've got the ceramic dish at 17.8 degrees, but the cold spot is the plastic dish at 16 degrees. So the drops on the plastic dish are cooler because it's not as good at conducting warmth to them. And you can even see on here the area around the drops on the ceramic dish are cooler because heat is conducted to the drop, whereas on the plastic, the temperature gradient is much steeper. But there's more to it than that because on the ceramic dish, the drops kind of form a bead, and on the ceramic, they kind of flatten out because the water is attracted to the ceramic, not so much to the plastic, which is more hydrophobic. And then as the water evaporates, the drop on the ceramic just kind of flattens out, whereas on the plastic, the drop actually shrinks in size, so it always has a smaller surface area than the drops on the ceramic do. So the drops on the ceramic are bigger and warmer, and that's why they evaporate twice as fast. But my impression is that the difference is more dramatic than that, so let's just try it with dishes in a dish rack. And scrubbing through that time lapse, we can see the water kind of runs off the ceramic dish in the first 16 minutes or so, whereas on the plastic dish, we have a few drops, but basically the water kind of slid off the dish before I even got it into the rack because it's hydrophobic. So at least initially you could say that the plastic dish dries way faster because the water all just kind of slides off of it before I even get it into the rack. Now the drops that do remain actually take much longer to evaporate than they did on the ceramic dish. Here they're gone at 23 minutes. These ones, that takes 57 minutes for those last drops to disappear. Next I was curious if the water being soapy makes a difference to how it sticks. So one tub is soapy, the other is plain. Soapy, plain water, and the water sticks to the soapy one a little bit and runs down it just like it did on the ceramic one, although about twice as fast. And the larger drops get taken with that, whereas this one has drops left on it, but beyond that they dry the same. The dishwash liquid is a surfactant, so it overcomes the hydrophobic nature of the dish, although it's normal to rinse dishes before you dry them, so that example isn't really all that important. But it reminds me of back in the days developing black and white film, adding wetting agent for the final rinse so that water drops would roll off the film better and not make water stains. Now we don't actually use these disposable plastic plates, it was more for a side-by-side comparison. My experience is more with these sorts of things, so let's test that. With these not as new and smooth, I have a lot more water droplets that stuck to it, and then as time progresses, they do dry slower. So waiting for the drops to come off of this one, still got one here. So we're at over an hour, still have a drop and some drops on here. But what's the very slowest is this disposable plastic cup here, where we have a drop right here that even after I stopped the test after almost 2 hours, we still have drops on it. Probably because it's the thinnest, so it was worse at conducting heat to the drops. But there's also some ridges here and here, so a larger drop was able to get stuck to it. So the way I see it, it's more about heat conduction and the way the drops behave than temperature retention of the ceramic dishes that makes them dry faster. In fact, I tried a ceramic dish in hot water and one in cold water right next to each other, and basically the hot dish got cold way before it got dry. So the ceramic dishes dry faster because they stay flatter on the ceramic dish, which means they have more surface area, and they stay warmer because more warmth is conducted to them from the rest of the dish, Whereas on plastic dishes, you got these small beads that are very cold with little surface area, so they just take longer to dry. And this video is sponsored by Topdon, who make this camera. So the TC004 Mini costs substantially less and is also smaller with a smaller screen than the TC004. It also has a lower resolution sensor, but its field of view is actually a fair bit narrower than the TC004. So even with a lower resolution sensor, the angular resolution it can resolve on the front is about the same. And the price of this one is just over half of this one regularly, but there's a promotion on for this one right now, which makes it quite a bit less than half the price of this one. Which is very nice because infrared cameras are just so useful, but they're not cheap.